Okay, so we got this integral, and we want to integrate it. And truthfully, we got to use a u sub, and then another sub, and a trig identity. So there's going to be a lot of things that's going to happen here. And we got to be careful. We don't want to mess anything up. Now, note, let's start by bothering with this. So we let u equal 3x. Then we see that du is equal to 3 dx. That's not that big of a deal, but note that we changed from x into u, so we should also change our bounds. So x into u. X was originally pi over 6, 0. So what does that turn into? That turns into pi over 2 and 0. Okay. So again, what does this mean? Well, we have this new integral that is from pi over 2 to 0, and it's cosine cubed u, sine squared u, du. Okay. Now we want to use this identity, sine squared u plus cosine squared u is equal to 1. We want to use that identity. Now, when there is a odd power and an even power, right, this is the cubed, this is the squared, what you want to do is try to make them the same power. So specifically we want, well, that's not exactly true. Actually, you would want to make them different powers. But what I mean is you want to get just one cosine by itself or either one sine by itself and have everything else as either cosines and sines. And you'll see what I mean in a second. So I'm going to write cosine squared u as 1 minus sine squared u. So then I could rewrite this integral like this, right? Cosine u, and then 1 minus sine squared u, sine squared u, du. Like, that's exactly the same thing, right? I just used the identity to rewrite, right? This is, right over here, this is cosine cubed. This is technically cosine cubed, so I didn't do anything. I didn't do anything wrong. Okay, now I want to change my... I want to do some cancellation. I mean, I want to get out of this trigonometry and get into polynomial. So let me just let v equal what? I'll let v equal sine u. The reason why I'm going to let it equal sine u and not cosine u is because if I let it equal cosine u, nothing's going to cancel. If I let it equal sine u, only sine u, not sine squared u, just sine u, I can get things to cancel. So then you see I get dv is equal to cosine u du. Again, when you change your coordinates, you got to change your bounds. U was originally from 0 and pi over 2. And then now it's going to be from 0 to 1. So I have this new integral. 1 second. I think I saw the fact that I forgot my 1 over 3. Because look at this guy right here. Hence, dx is 1 over 3 du. My bad. That's the only thing I forgot. Everything else is correct. Don't worry about it. So I get 1 over 3. And then the cosine u, I'm going to show you guys. Cosine u du, there's a cosine u, and there's a du. So I could make the substitution completely work. Right, so what do I get here? I just get 1 minus u squared. Oh, my bad, not u. 1 minus v squared, and dv. Right, that's all that happens, and I get 1/3. And then that's going to become v cubed over 3 minus v to the 5th over 5, evaluated from 1 to 0. And this is going to equal to 1/3 and 1 over 3 minus 1 over 5. And yes, guys, I'm doing a bit of math in my head right here, but this is a simple polynomial that you could just use the linearity principle of the integral and write it out more if you wanted to see more work, but I'm trying to save you guys some time. So 1/3 minus 1/5, that's the same thing as what? 14 5 minus 3/15, so 2/15 times 1/3 on the outside. So 2/15 times 1/3 is 2 times 2 over 45. Our answer is 2 over 45. There you go. Just in the nick of space. Got it. To recap, you want to get rid of that inner. Let's do a substitution. When you do a substitution, what do you have to do? You have to change your bounds. Okay. You want to get rid of the sines and cosines because you don't like them? Good. Use a trigonometric property. Okay, and then when you use that trigonometric property, what can you do? Then you can use another substitution. You can use another change of coordinates, right? And turn it from sines and cosines into algebra. Or, into a polynomial. So then you get your answer, 2 over 45. That's it.